Ever feel like you're drowning? Just trying to keep your head above water with all the new research and guidelines. It's a lot to keep up with.
Yeah, it really is.
Today, we're diving deep into how we deal with all this complexity in medicine. Specifically, we're looking at this article, Accounting for Complexity in Medical Education, a model of adaptive behavior in medicine.
And what this article really gets at is this idea that, maybe the way we traditionally approach medical training, with all the emphasis on the scientific method and breaking things down, maybe it's missing something. The real world of patient care is messy, right?
It is.
Yeah.
It's not always a neat and tidy textbook case.
Hmm.
So in this deep dive, we'll explore this tension between reductionist science, that breaking things down to their parts approach, and the need for something more adaptive, more flexible in medicine. We're pulling out the key takeaways from this research, giving you a shortcut to this crucial perspective.
Perfect.
Okay, let's jump in.
So first things first, let's acknowledge the elephant in the room. Medicine is complex. It just is.
Oh, absolutely.
From the way our bodies work, to the way healthcare systems are organized, to, of course, the individual needs of each patient, it's all interconnected.
And this article gives a really clear definition of what makes a problem complex. It's not just about a lot of factors being involved. It's about how those factors are always interacting, influencing each other, sometimes in ways that are hard to predict.
Absolutely.
And sometimes the goals themselves are unclear or even in conflict with each other. Like, think about a patient who has diabetes, heart disease, and kidney problems.
Yeah.
Treating one condition can totally throw things off with the others. And what might be the best course of action for one problem might make another problem worse. The article actually has a really helpful figure that lays out how this all works. The interplay of many factors, the unclear connections, and those sometimes conflicting goals. That's what makes these problems so complex.
You got it. And what's so interesting is that the article brings up the butterfly effect to really drive this point home.
Right, that idea that even a tiny change somewhere can have huge ripple effects throughout the whole system.
Exactly. Whether it's a small change in a biological system or even a tiny policy change in a hospital, the consequences can be surprisingly big and totally unpredictable. That's the nature of complexity in medicine and disease. And it kind of goes against the grain of how we've traditionally thought about training doctors, which is more reductionist, right?
It does. For a long time, medical education has really emphasized that scientific reductionist approach. I mean, it goes all the way back to the Flexner Report.
Yeah.
That was over a century ago, and it really pushed for a more scientific basis for medical education.
For sure.
So you spend years in med school immersed in the basic sciences, often taught by specialists who are incredibly knowledgeable in their very specific fields. And the idea was, if you understand all the fundamental building blocks, that you can understand the bigger picture of health and disease.
Makes sense in theory. And that reductionist perspective has really shaped how we create medical knowledge and how we use it in practice. We focus on specific disease mechanisms, develop targeted treatments, and design research studies that isolate variables to find those clear cause and effect relationships. The article even argues that medical education has essentially become this fundamentally reductionist endeavor.
Which might lead to some problems, right? I mean, is that reductionist approach enough to prepare doctors for the complex reality of patient care?
That's the million-dollar question, and the article calls it the practice gap. There's often a disconnect between that deep scientific knowledge and actually being able to solve the multifaceted problems you face every day in the clinic.
100%.
And the article gives a few examples that I think will really resonate with you. Like, have you ever tried to apply a clinical guideline for a specific condition to a patient who has a bunch of other health issues?
Oh, all the time.
It happens all the time. And the problem is those guidelines often don't account for all those complex interactions. Another example, hospitals sometimes struggle to implement those outpatient care plans that we know can reduce readmissions. Like, for heart failure patients, we have the knowledge, but putting it into practice in a complex system, not so simple.
Definitely. And this complexity isn't just limited to individual patients or even hospitals, right? I mean, think about policymakers.
Oh, yeah.
They're always talking about the triple aim, improving patient experience, population health, and lowering costs. But those aims are all intertwined.
They are.
It's a complex web. What helps one might hurt another. And then there's the whole issue of specialization in healthcare. I mean, it's great to have experts, but it can also lead to fragmented care.
Which can actually negatively impact quality, increase costs, and affect how patients even access the system in the first place.
It's complicated, to say the least.
It is. And what's also really interesting is that the article suggests this intense focus on reductionist science in med school might actually hinder the development of some crucial skills for dealing with these complex situations. Things like moral reasoning, how we think about knowledge itself, and our ability to handle uncertainty. Those things seem to stall during those intense basic science years.
And the article suggests there might be some serious consequences to that stalling.
Yeah.
It could affect clinical performance, contribute to higher healthcare costs, and even make it harder for us to accept and learn from medical errors, which is so important. They even suggest there might be a link to burnout. So, what's the solution? How do we bridge this gap between reductionist knowledge and the complex realities of patient care?
Well, the article introduces this concept of systems thinking.
Okay, systems thinking.
It's a way to connect that essential reductionist knowledge with the real world of patient care. And it's actually not a new idea. It started in biology a while back, when scientists realized that just breaking things down into smaller and smaller parts wasn't enough to understand how living organisms actually work.
It's like trying to understand a car by looking at each individual part in isolation.
Exactly. You miss the big picture of how all those parts work together. And since then, systems thinking has spread to all sorts of fields, ecology, engineering, you name it. But here's the key, and the article really emphasizes this. Systems thinking in medicine isn't about just having rigid procedures or algorithms, what they call systematic thinking. It's much more about being adaptable, being able to learn and adjust as you go.
So it's less about following a strict recipe and more about understanding the ingredients and how they interact.
Exactly. You need to be able to improvise a little in the kitchen. That distinction between systematic and adaptive systems thinking is really important because a rigid, systematic approach might work in a simple, predictable system. But when you're dealing with the complexities of medicine, you need to be able to adapt. You need to be able to see how everything is connected and adjust your approach accordingly. And this actually ties into concepts that you're probably already familiar with, like teamwork and continuous quality improvement.
They're both about being responsive and constantly learning and adapting, right?
Spot on. So let's take this a step further and talk about complex adaptive systems, or CAS. The article breaks down these systems in a way that directly relates to what you do every day. First, you have individual elements, each with its own unique characteristics. Think of these as the individual doctors, nurses, and other healthcare professionals, each with their own knowledge and skills.
Got it. So each of us is an element in this complex system.
Yeah.
Then what?
Then there's an attractor, something that draws these elements together and creates a sense of purpose and organization. In medicine, you could think of professionalism as that attractor. It's the shared ethical values, the mission of caring for patients. That's what unites us all.
That's the common goal that everyone's working towards. Okay, what else?
And then there's this idea of adaptive capacity. That means the elements themselves can change and adapt. And in your case, that's you, the physician, using your clinical judgment and experience to adapt to the unique needs of each patient.
Right, because every patient is different, and a one-size-fits-all approach isn't going to cut it.
Exactly. And lastly, there's this absence of excessive centralized control. Think about physician autonomy. That's a key part of it. It allows for that flexibility and innovation that's so crucial in complex situations.
I like how the article compares medicine to a jazz band.
Oh, yeah, it's a great analogy.
You have all these talented individuals, each with their own strengths. But it's the improvisation, the responsiveness to each other, all driven by the shared goal of creating beautiful music that makes it work. That's how I picture CAS in healthcare.
Perfectly put. And what's fascinating about these CIS dynamics is that they're always in motion. They're constantly reacting to changes in the environment. The elements are learning and evolving as they interact with each other. And the entire system is always trying to optimize itself based on that central attractor professionalism in our case.
Makes sense. It's like how a medical team in a busy ER is always adjusting their approach based on what's happening around them.
Yeah.
They're constantly communicating, making decisions on the fly, all with the goal of providing the best care possible.
Absolutely. And those dynamic features directly connect to some core systems concepts in medicine.
Like teamwork and continuous quality improvement.
You got it. It's all about being responsive and adaptable in a complex and ever-changing environment. So what does this mean for medical education? And for you, the practicing physician who's already out there dealing with all this complexity?
Yeah, what are the practical implications?
Well, the article makes a strong case that we need to shift our focus. Instead of just focusing on rigid protocols and procedures, we need to cultivate adaptability.
Because sometimes ticking all the boxes isn't enough. or might
Right.
even be the wrong thing to do.
Right. In complex situations, you need to be able to think critically, use your judgment, and adapt your approach. And this new understanding of CAS also gives us a fresh perspective on professionalism and autonomy.
How so?
Well, professionalism becomes less about following a set of rules and more like an internal compass. It's about having a strong ethical foundation that guides you through those ambiguous situations where there isn't a clear right or wrong answer. And autonomy, it's not just a perk for doctors, it's essential. It allows for that adaptive behavior, that ability to innovate and solve problems at the bedside.
Interesting. So it's not just about having the knowledge, it's about how you use it, how you adapt it to each unique situation.
Precisely. And the article even suggests we rethink how we view medical knowledge and technology. They become tools that you, the adaptive professional, use wisely and practically rather than being the things that define you.
It's about using those tools to achieve the best possible outcome for each patient.
Makes sense.
Now, the article also talks about some specific ways we can improve medical education to better prepare future doctors for this complex world. What are some of those ideas?
One key area is identifying and recruiting trainees who already have a natural inclination towards adaptability.
Okay, so looking beyond just grades and test scores.
Exactly. They talk about a broader definition of intelligence, including qualities like epistemic humility, recognizing the limits of your own knowledge, and being comfortable with ambiguity and uncertainty and having a strong sense of moral reasoning. They even mention this WICS model, which stands for wisdom, intelligence, and creativity, and how incorporating these broader assessments into admissions could actually be a better predictor of success and reduce disparities. So even from the very start, they're looking for those qualities that might make you a more resilient and effective doctor down the line.
So it's about recognizing that there's more to being a good doctor than just being book smart. You need those other qualities, those human qualities, to really thrive in this complex world. Now, the article also talks a lot about epistemic humility.
Yeah, which is essentially about recognizing that you don't know everything and being okay with that. It's about acknowledging the uncertainty that's inherent in medicine, especially when you're applying general scientific knowledge to a specific individual patient. It's about asking yourself, what don't I know about this particular patient? What else could be going on? Even when the guidelines seem clear-cut, there's always more to learn.
And that's so important, right? Because if we're not humble, if we think we have all the answers, then we're not open to learning new things. We're not open to adapting our approach.
Exactly. And the article argues that traditional medical training doesn't always do a good job of addressing this uncertainty. We might learn about evidence-based medicine and guidelines, but we don't always learn to question those guidelines, to think critically about their limitations.
Which can lead to mistakes, right?
Mhm.
Like misinterpreting data, confusing statistical significance with real-world certainty, or applying evidence without really considering the individual patient's circumstances.
Absolutely. And the article is really clear that blindly following scientific findings without that critical thinking and humility can actually hinder our ability to adapt and provide the best possible care.
But it's not about throwing out all the knowledge and guidelines, right?
No, not at all. It's about using them wisely. It's about recognizing their limitations, their potential biases, and being willing to adjust your approach based on the unique needs of each patient.
So it's a balance. You need the knowledge, but you also need the humility to know that you don't know everything.
Exactly. It's about finding that sweet spot. And the article even suggests ways to teach this kind of critical thinking, like using real-world cases to help students analyze those underlying assumptions we often make in scientific inference.
Sounds like a good plan.
Yeah.
Now, another interesting point the article brings up is this idea of excessive systematization, this tendency to create more and more rigid systems and protocols in an attempt to manage complexity.
It's a natural human response, especially in a field like medicine where we value measurement and standardization. But the article raises some concerns about this approach.
I can see that.
They use competency-based medical education, or CBME, as an example. And while CBME can be useful for assessing some aspects of training, it might not be the best way to evaluate more complex competencies, because in real life, there's often not one right answer, not one perfect way to do things.
You have to be able to think on your feet and make judgment calls. And sometimes the best course of action isn't clear-cut.
Right, and the article argues that the most important measure of success in medicine is a positive clinical outcome for the patient.
Ultimately, that's what matters.
Exactly. So they suggest maybe we need to assess adaptive competence separately from technical skills to make sure we're not inadvertently rewarding rigid behavior when a more flexible approach is needed. So what are some practical ways to encourage adaptive behavior in medical education? The article dives into that too, which is helpful for your own professional development as well.
Yeah, what are some of those ideas?
Well, they stress that excellence in complex systems isn't about achieving some perfect standardized behavior. It's about that continuous effort to respond to new information, learn from experience, and constantly improve. And this should always be guided by your core professional values and those real-world interactions with patients.
It's about being a lifelong learner, always striving to get better.
Exactly. And they contrast this with what they call systematic learning, which is more like traditional classroom learning, guidelines, standardized simulations. It's necessary, but it's not enough.
Yeah.
You also need that systems thinking learning, which happens through real-world experience, reflection, and adaptation.
So it's not just about what you learn in the classroom. It's about how you apply that knowledge in the real world and how you learn and grow from those experiences.
Absolutely. And this leads to a really interesting proposition. They question the traditional two-part structure of medical education.
You mean preclinical years followed by clinical rotations?
Yeah. They suggest that maybe there are benefits to integrating basic science learning and patient care responsibilities from the very beginning of medical school.
So instead of having those two distinct phases, it would be more interwoven. That actually makes a lot of sense.
It does. It could really help students connect the dots between theory and practice, and it could help them develop those professional values and problem-solving skills much earlier in their training. And ultimately, this approach would really emphasize the importance of adaptive behavior, which, as we've been talking about, is so crucial in providing high-quality care.
It's about recognizing that being a good doctor is about more than just memorizing facts and following protocols. It's about being able to think critically, adapt to new situations, and make sound judgments in a complex and ever-changing environment.
Couldn't have said it better myself.
So, to sum it all up for our listeners, what are the key takeaways from this deep dive into the article?
Well, I think the biggest takeaway is that we need a shift in mindset.
Okay, a shift in mindset.
We need to move beyond that purely reductionist view of medicine, both in how we train new doctors and how we approach our own practice. And we need to really embrace the principles of adaptive behavior and systems thinking.
It's about recognizing that complexity is inherent in medicine and that we need to be equipped to deal with that complexity. And the article ends with a call to action, right?
It does. They call for adaptive leadership in medical education. It's about really integrating these concepts into how we teach and mentor the next generation of physicians.
And I think it's a call to action for all of us, not just educators. We all need to be thinking about how we can foster adaptability in ourselves and in our colleagues. So for our listeners out there, I want to leave you with a question. How might incorporating these principles of adaptive behavior not just improve the care you provide to your patients, but also help you grow professionally, become more resilient, and thrive in the face of all the challenges that medicine throws your way? Take some time to reflect on how these ideas might apply to your own unique practice and the complexities you face every day.
That's a great question. And hopefully, this deep dive has given you a new lens through which to view medical training and practice.
And maybe even spark some new ideas and conversations. Thanks for joining us.
Thanks, everyone.